Okay, welcome to part 2 of lesson 35 on factoring GCF, the greatest common factor, and then also canceling. So we just covered the video or the concept of factoring out a greatest common factor in the previous video. This video will focus on canceling. All right, again, this is a topic that has already been discussed in concept, but we haven't seen problems exactly like this. And it all kind of stems from a basic concept of how do you break down a number like 24 over 64. All right, everybody is familiar at this point in Algebra 1 with how to reduce numbers. So we take a number like 24 over 64 and we recognize that it's made up of a bunch of prime numbers or prime factors multiplied together. So 24, if I come off to the side and break it apart, 24 is 2 times 12, and 12 is 2 times 6, and 6 is 2 times 3. And so we got our little hockey stick here, and 24 is technically 2 times 2 times 2 times 3. All right? We can do the same thing with 64. If I take 64 and I break it down, I get 2 times 32, which is 2 times 16, which is 2 times 8, which is 2 times 4, which of course is 2 times 2. And so 64 is all these 2's, it's basically 2 to the 6th power, right? 2 times 2 times 2 times 2 times 2 times 2. There's 6 of them. So we get 2 times 2 times 2 times 2 times 2 times 2. 6 factors of 2. All right. And then we recognize, oh wait, 3 of those factors on the top are going to reduce 3 of those factors on the bottom, and they disappear. So what am I left with? I'm left with 3 on the top and 2 times 2 times 2, which is 8 on the bottom. Now, that is as much nitty-gritty detail as we can possibly get in how to reduce 24 over 64. You're breaking it down and canceling off any of the factors that match from the top and the bottom, because when you divide 2 by 2, you get 1. When you divide this 2 by this 2, you get 1. And the same thing with the other set of 2's. So what are we left with? We're left with a 3 on the top and then all of these on the bottom. Another way to think about this is, what is the greatest common factor among both 24 and 64? What number goes into both 24 and 64? And most of you, if you think about it for just a second, can probably come up with that. The greatest factor that is in common is 8. 24 is 3 times 8, and 64 is 8 times 8. And so what happens is you're reducing or you're dividing both of them by a factor of 8, and you're left, of course, with the answer we already got, 3/8. All right? Well, that's what's going to happen with algebraic expressions. In this, we were doing it with a numeral, in this 24 over 64, but now we're going to talk about it when it comes to expressions, example 4, 5, and 6. If you have a factor on the top and the bottom that is in common, as long as everything is multiplied here, this is technically 3 times p plus 3. And this in the bottom is technically 3 times 1. So they are factors. 3 times, if a factor is a part of multiplication, so these are parts of multiplication. If they are parts of multiplication and I have one in the top and in the bottom, then I can cancel them off. I can reduce them. So what am I left with? I am left with simply p plus 3, or p plus 3 over 1, but I don't really need to write it over 1. P plus 3, final answer. All right, but that one's really simple because it was already factored. In example 5, we need to factor it. So we begin by saying in this numerator, there is a 4 in common. I can pull a 4 off of both of these terms, this term and this term. If I factor out a 4 from the first term here, then I'm going to be left with 1 in its place, for the same reason when we factored out 2a squared b squared in this example, we were left with a 1 in its place. All right? So if I'm left with a 1 in that position, then in this position, I'm left with a minus x. The 4 is divided off, so minus x. And in the bottom, I didn't do anything. I still have the minus 4. Well, now that they are parts of multiplication, this is 4 times 1 minus x, and this is technically 4 times 1. Now that they're parts of multiplication, I can cross them off. So I'm left with 1 minus x. Final answer. All right? And we can do it again in the next example. In the next example, I can factor off 7x from the top. So 7 goes into 7, 7 goes into 49, so I can pull out a 7. X goes into x, and x goes into x squared. I have at least one factor of x in both this term and this term. So my GCF is 7x. Well, what's left? If I pull out 7x from this whole term, well, then I'm left with 1. If I pull a 7 off of this, I'm left with a minus 7. When I say pull off, I'm not subtracting, as we know. I am dividing 7. And then, of course, I divided off an x as well, so I have an x left because there were two x's, two factors of x. And what's on the bottom? Well, 7x. So as we've done in the previous two examples, now that I have 7x on the top as part of a multiplication, it is technically being multiplied by this quantity, and I have 7x on the bottom, I can cross them off. So what am I left with? 1 minus 7x. All right, final answer. Now there is a tendency for students to just look at this original problem and go, oh, well, there's a 7 there and 7 there and 7 there. I can just reduce everything by a 7. And there's an x there, x there, x there. I can reduce everything by an x. That is true. You can do that because of the way this is oriented. It works. But I need to make sure that you're really careful, because what you can't do is on a problem, let's say I make one more up here. Let's say you had a problem like 12x over 3x plus, I don't know, let's go over 21. Yeah, that works. 3x over 21. In this problem, you need to make sure that you still understand the factoring concept that we had done up here. I can't just start willy-nilly crossing things off because I see that there's something alike. Particularly, I can't cross these x's off in this problem because this term does not have an x. And you'll see what I mean here in a second. So if I factor the bottom, I can't really factor the top, it's 12x. But on the bottom, I can take a 3 out. And what am I left with? I'm left with x plus 7. 3 times x is 3x, and 3 times 7 gives me the 21. So now, if I try to reduce, only a factor of 3 will reduce. The 3 goes into 3 once, and the 3 goes into 12 4 times. So I'm left with 4x on the top and x plus 7 on the bottom. So again, I'm factoring out only a 3, and so since there's only a factor of 3 that's in common with the numerator, I can only reduce by a factor of 3. All right? So be careful you're not crossing entire pieces off. Only cross off factors that are in common. All right? That concludes lesson 35. Hopefully that all made sense. You may move on to the homework.